Let's take a look at an example. We have two columns of matrices here. Each matrix in column A is similar to exactly one matrix in column B. By considering the trace, determinant, and rank of each matrix, use process of elimination to match similar matrices. Okay, so remember that if two matrices are similar, they will for sure have the same trace. Two similar matrices will have the same determinant. Two similar matrices will have the same rank. So we want to look at these different features of the matrices and kind of narrow down which matrix in column A is similar to which matrix in column B. All right. Now I'm going to start with the simplest case, the trace. Trace is the easiest to calculate, and we'll work our way up to these more difficult values to calculate as we go on, but hopefully we'll be able to kind of winnow down what's going on here. All right, so let's calculate the trace of each matrix. Remember, the trace is just the sum of its elements along its main diagonal. So for this first matrix, just add up along the main diagonal. -2 plus 1 plus -9 is -10. For the second one, it's also -10. For the third matrix, we get -6. And for the fourth matrix, we get -10. Okay? Okay, now let's do column B. We get -5 plus 0 plus -1 is -6, first matrix. For the second matrix, -2 plus 1 plus -9 is -10. And these other ones also better be -10, right? Because we know each one's going to be similar. So we better have, if we have 3 -10s in column A, we should have 3 -10s in column B. And we could see, okay, yeah, second matrix is -10, trace of the third matrix, -5 plus 15 plus -20, that's going to be -10. Okay, so checks out. Now, I know two similar matrices must have the same trace. And since I know every matrix in column A is similar to exactly one matrix in column B, I can right now already, I can say that this matrix and this matrix are similar because they're the only two matrices that have the same, that have trace of -6. Okay? All right. Next, let's do the determinant. Now, I only have to do this for the matrices that are left. All right? So for this first matrix, I'm going to expand along the first column. So -2 times -9 minus 0. So -2 times -9 is +18. Determinant of this matrix, we have a row of 0, so it's going to be 0. I can skip this matrix. I've already found its match. And for this last matrix, I have a column of 0, so the determinant's going to be 0. Okay, now let's go to column 2. I could skip this matrix. I've already found its match. For B, the determinant here, I'm going to get, let's expand along the first row, -2 times -9 minus 0. -2 times -9 is 18. And for the other entries, it'll just be 0. So it's just going to be +18. I think I might have said -18, but it's +18. To determine here, I've got a row of 0, so I get 0. And for this one, what am I going to get? So let's expand along the first column. -5. I have 15 times -20, but then I'm subtracting -15 times 20. So those two will cancel. I'll just get 0 from that product, right? Big numbers, what would I get? 300. So I get negative 300 minus negative 300. Negative 300 minus negative 300 is 0. Times negative 5 is 0. And then the other two entries from column 1 would also give me 0. So I'll get 0. Okay? All right, so based on those that have a determinant, I could see that this matrix and this matrix must be similar. They both have the same trace, they both have the same determinant. They're the only two matrices with that same trace and determinant. Okay? All right, I still have two matrices left to check. I need to check this matrix, and I need to check this matrix from column A, and I need to check this matrix and this matrix from column B. The last element that the problem asks me to check is the rank of each matrix. All right. So for this, we will pull out our calculator. We're going to find the reduced row echelon form of our matrices. All right. So let me pull this over here. All right. So I'm going to work on. Let me actually. There we go. I'm going to work on find the rank of this matrix first. Okay. Now for some of these, you might be able to just look at and figure it out. This is one that I could look at and I know the rank, but if not, just use the calculator. That's fine. Okay. So let's put in the calculator. First row is 0, second row 10, negative 10, 0, third row 20, negative 20, 0. So there's its reduced row echelon form. I can see that there is only one non-zero row here. So the rank for this matrix is going to be 1. Okay. The other matrix that I still have to check that I haven't found a match for yet is this last matrix. So let's find the rank for that last matrix. And I called that one matrix A, so let's call this B just to keep things different. Get negative 5, 0, 0, 5, 0, 5, 0, 0, negative 5, find the reduced row echelon form of the matrix. Oh, I made a mistake here. Oh, I forgot a comma. Try it again. There we go. I have two non-zero rows, the rank's 2. Okay, so they have different ranks, so that should narrow it down. I should be able to find exactly which one matches which at this point. So now let's find the rank of the other two matrices in column B that I haven't yet paired. That's this matrix and this matrix. So let's do the third matrix in column B. First row is all zeros. Second row, negative 10, negative 10, 0. Third row, 10, 10, 0. Find the reduced row echelon form of C. I did it again. Don't forget your commas. I have one non-zero row in the matrix. The rank is 1. Okay, and at this point, you could probably figure it out by process of elimination. Since every matrix in column A match is similar to a matrix in column B, this matrix and this matrix must be similar. They have the same trace, they have the same determinant, they have the same rank. This matrix cannot be similar to this matrix because it has a different rank. So these two matrices must be similar. Now, I didn't actually find the rank for this one, but I don't need to because it's the last one available. Since this has rank 2, this must also have rank 2. You could double check that if you want. Plug it into your calculator. Okay, so these two must be similar. They're the only two that are unpaired.